Hello guys, welcome back to VC Tech. If you've ever wondered how a private device inside a network gets its own public IP address on the internet, then this video is for you. In this video, I'm going to explain Static NAT from the basics, what it is, why we use it, how one-to-one mapping is done, and how to configure Static NAT step by step on a Cisco router. By the end of this video, you will clearly understand when Static NAT is required and where it should be placed in a network, and why it is commonly used for servers like web server, email server, and VPN system. With that being said, let's have a bit of a knowledge of what Static NAT is. A Static NAT creates a permanent one-to-one mapping between the inside local and the inside global. Now, the inside local are the private IP addresses in the network, while the inside global are the public IP address that will be assigning to the private IP address. So whenever they want to use the internet, they are going to use the public IP address. So this allows internal devices to be reachable from the internet. Why Static NAT is used? Static NAT is used when a device must have a fixed or a permanent public IP address. And devices that require those fixed public IP address are web servers, mail servers, VPN gateways, public facing application. How does Static NAT work? Static NAT is always active, no port translation, inbound and outbound traffic allowed. Now, an example to this Static NAT is every IP address in the network has its own public IP address. So this is 192.168.1.10, the private IP address, and it has a public IP address of 203.0.113.10. This is how a static IP address is being configured on a router. Now let's head over to our Cisco lab and configure Static NAT on the router to enable this local device to communicate with this local device using a public IP address. Now let's check on the router. Let's check our NAT translation and see what we are going to get since we've not configured NAT on the router. So do show IP NAT translation, and as you can see, there was nothing because we've not configured NAT on the router. Let's also try to ping from this local device and see what's going to happen. Yes, we are able to communicate with the other local device because I've already configured a routing protocol on the router. Let's get into our main objective for today's tutorial, which is configuring Static NAT on a router. So let's configure our Static NAT on the router. We want to say IP NAT, and we also want to specify that we want to convert the inside private IP address to a public IP. We also want to say source, and for this we want to be using static. Now we have to specify an IP address. Remember, Static NAT is a one-to-one mapping, and assuming we have 10 devices on this local area network, all the 10 devices will need to have a 10 public IP address. So since we have 2 host devices on this local area network, and for this tutorial, let's assign a public IP address to them. So first, let's say the private IP address is 192.168.1.5. We want to assign a public IP address to this host device. So whenever it wants to use the internet, it's going to use the public IP address. So we can do that by saying 203.10.169, and we want to give that private IP address a public IP address of .5. We also want to do the same for the second local area network, which has the IP address of 192.168.1.6. We change that to 6, and we also change the public IP address from 203.10.169.6. So by doing this, we've created a static NAT on the router, giving the host devices a public IP address. So whenever they want to use the internet, they use the public IP address to access the internet. Let's also do the same configuration on the second router before we place our static NAT to the interface. So we say IP NAT inside. We want to specify the source, and we also want to say this is a static NAT, and the host devices for this local area network is 192.168.2.5. We also want to assign public IP address of 203.10.109.5, and we do the same for the second device that has 2.6 and the public IP address of 203.10.109.6. Now we've created our static NAT on both routers, but it is not active now until we apply them to an interface. So on this router over here, we are going to say interface gig 0/1. We want the translation to be done on the inside interface, which is interface gig 0/1. So we say IP NAT inside. We specify that interface as inside since it's facing the local area network, and interface gig 0/0, which is facing the outside network, becomes the IP NAT outside. IP NAT outside. Now, if we try to check our translation table once again, we are going to see that the private IP address, they now have a public IP address to go outside the network. So do show IP NAT translation. As you can see, 192.168.1.5 now has a public IP address of 203.10.169.5, as well as 192.168.1.6 has the IP address of 203.10.169.6. Let's also do the same for the second router, and then we try to ping and see what's going to happen. So interface gig 0/0, this will be taking IP NAT outside, and interface gig 0/1 will be taking IP NAT inside. IP NAT inside. As if we check, interface gig 0/1 is this interface over here. It is facing the local area network, while interface gig 0/2, this interface facing the internet. Now let's try to ping from this host device. But before we do that, let me explain what this means. So the outside local is the device that we are trying to get to, while the outside global is the public IP address of the private IP that we are trying to get to. So as we go to ping right now, this IP address right here is the outside local that we are trying to get to, which is 192.168.2.5. Now we will be able to reach that device through its public IP address. As you can see over here, it has a public IP address of 203.10.109.5. Let's also go and check our routing table and see what we got. So as you can see, we have our inside local IP address of 192.168.1.5, and we also have the public IP address of 203.10.169.5. And we were trying to ping or communicate with 192.168.2.5, as we also have its public IP address of 203.10.109.5, as well as we have over here. So this is how a static NAT works. It translates the private IP address to a public IP address. So whenever host devices want to access the internet, they use the public IP address, limiting the risk of being attacked. Let's also do the same from this device and see what's going to happen. First, let's try to ping one of the device. So we are pinging .6. Then we try to see our do show NAT translation table, do show IP NAT translation table. As you can also see, we were trying to ping 192.168.1.6 that has the public IP address of 203.169.6, and the protocol that it is showing us right here is that we are using an ICMP packet, which is the ping packet. That is the protocol that we are using to get to this outside local. The outside local is the private IP address of this local area network over here. Since I was pinging from this device, the outside local is this private device, this private IP address over here. Now the outside local of this is the IP address of 192.168.1.6, as we have here. This host device right here is 192.168.1.6, and it is being considered as the outside local on this router. Since we are using this device to ping that over there, we can also see that from here, 203.10.169.6. That's the public IP address for this host device over here, which is 192.168.6. We can also check our do show IP NAT statistics, IP NAT stats. It's going to show us that we have a total of two translation, 2 static NAT translation, and interface gig 0/0 is the outside interface, as we have here, and interface gig 0/1 is the inside interface. Guys, this is how we configure static NAT on a router, translating a private IP address to a public IP address to enable host devices in a local area network to communicate with another host device in a different local area network using a public IP address. On the next video, we'll be talking about dynamic NAT. So stay tuned, and if you haven't subscribed to this channel, smash the like button, subscribe, because this time we'll be talking about way more interesting stuff and how the network works. Thank you guys, and see you in the next video.